click OK to save this. It's letting me know once I've saved this plain text file as an AMUmail protected file, I no longer can save it as a plain text file. So I can't go back. That's okay. So the file's still sitting there. Let's close it. Let's now launch a hex editor to go take a look.
Do you delete the old version?
At our
We made a
protected
packet.
file, and I'm using a hex.
But that's a good question too. Is on this one, I think we're talking about redoing the video. Our intent is to never have a deciphered version. So really, what we want to do is show you opening and creating the file here, as opposed to taking a pre-prepared one that's sitting on disk unenciphered, in plain text.
Editor, because the enciphered file, if you try and open it in a in Notepad, I mean, it looks pretty bad. So, here.
So the on file format, is that then encrypted using your profile, or so how do you scramble it? So what do you just do standard encryption using
I can
your?
tell you, but I'd have to kill you. No, this is because let me answer that honestly. There are some components where we use standard encryption. There's reasons for that, but we have our own patents on.
You have your own what?
Patents on. We have a couple of things that we do.
You're generating a pad. You're doing your. Okay. I'll let you do.
Okay. For your purposes only, and the rest of you people, but imagine this. Let me put the challenge to you this way. You figure it out for yourself. Let's say hypothetically you want to solve a problem of three-legged stool in cybersecurity or in Cipher, which is given a key, given a source, given and you need two of those, and given an output. And when you need two of those, you can determine the third. Any competent programmer can. So the issue becomes, why is that relationship fixed? Right? If you can break the fixation of that relationship so that no two of the unenciphered and the enciphered can be taken to elicit the key, or vice versa, that you can take the key and the...
Don't initialization vectors solve that problem?
They do if you don't have a quantum computer, and they do if you don't have a quantum computer, if you don't have enough time resources.
We don't have a quantum computer right now, right? AES is not going to be,
okay.
Quantum computers and AES,
okay. We need to talk about the practical and theoretical.
Go ahead, what do you use? So that just describes.
Okay. Anyway, remember we talked about the randomness of his machine, and well, we did. They weren't in the room at the time. Okay, so the deal is this: he has typed things on the computer that don't exist on any other computer in the world in the same context with everything else on the computer. If you did a hash of that entire body right now, would you agree that's a unique environment? Would you get a hash that was unique from any other?
Yeah. Okay.
Now, would you say that if you took a subset of that hash, you took some things you know that more likely to be unique than other things, and you took a subset of that, you'd get a hash that nothing else.
Yeah, that's what cryptographic hashes are. Yeah.
Yeah, but they're not done on 65K keys. The issue here.
Well, that's what a pad is. So yeah.
Well, okay. As a practical matter, in actual implementation, we're trying to achieve two things: efficiency. And we're trying to achieve uniqueness, right? So we're going to take things that we know they're unique, and then we're going to mix them. What we're going to do is let's make it just. I'm not trying to make it simple out of disrespect to you. Obviously, I just want. This was the conversation that I was prepared to have, and we can have it, but it's going to take the rest of our time. So I'm going to address this very quickly. If I wanted to solve the three-legged problem, the three-stool problem, what I do is this. There's a way everybody else goes out and does it, and there's a way we do it. And what we do is this. We take that randomness that we extract from that machine, and we do it before we accept the key, we take the target, we then inject randomness in a certain pattern known to us, right, rolling code, whatever it would be, inject anything before we encipher it, we then transmit it back, and then we apply the same rule on the other side. Now, in doing so, right, we now have because the randomness that we insinuated was both random in length and random in content, and was randomly seeded among the valid, because before we did the enciphering, we can have a situation where we can be assured of having random links within boundary conditions. You know, you don't want to make a 3K file into a 30,000 K file, but we have some limits in there. But now we have the issue where at any point in time we can generate a result of an encrypted result from something that is never going to be in two passes the same result, right? To the hacker, our target here is a hacker. Agreed?
That's a standard aspect of any crypto system so far. You haven't done anything that's unique yet.
No, I'm not.
So that's okay, that's only
No.
for, so that's
I
what
think we need,
you just asked me.
let's not level ourselves because we're
Yeah,
out of
yeah,
time,
yeah.
it's trying to continue to move forward.
I guess the simple question is, has anybody, you're essentially designing your own crypto system?
No. We are reassembling crypto systems, other people, because we have to stay with legacy, right? Nobody in their right mind goes out and invents a new thing and tries to invent new cryptography. That would be friggin' insane. We're not insane, okay? So, but what you can do is apply known cryptography things from other disciplines in a different order than what they normally do. Now, agreeing that could be done in discovery, the method can be done in discovery, but if you had 60, let's say you had 2 to the 64th ways of combining different subsets of little things, right? Let's say that you said, hey, I have a key here, or 2 to the 64th, some number. And based on that number alone, I have a number of different ways of assembling these different components ad hoc for any given one instance of encryption. All standardized pieces of encryption. We use every blowfish. We don't care about the individual, because the difficulty is in 2 things. The individual enciphering, they still have to do the AES, right? They still have to do the AES 256. If we go to SHA 5512, we have a section of that, right? But we mix the two up. So we have interleaved, we have a number of interleaved layers of these different technologies based on a random number that we start with, a C value. So at the end of the day, we are doing this for one and one only enciphering, right, of one deciphered result. And we're doing it in a way that we know, coming on the other side of it, where we're going to get our random. In other words, we have code, everything's done through code, right? We have code on one side, code on the other, that understands how to encipher and decipher these things. But we use standardized components because it is what we can. Am I satisfying your question? I don't know, because I don't know which question you want me to answer.
Well, let's.
You go back to 1866 and you can say.
I think I'm gonna respect everybody here and not go down the level of detail that I'm tempted to go.
Okay.
So why don't we do this, is we'll save that for a follow-up conversation.
Yeah.
And go ahead and continue your
Okay.
demo.
At least it's able to control the display a little bit. So here's the header, just our standard header, plain text file. Below that is the content of the file. And you can see it's all a bunch of enciphered text, just a bunch of gobbledygook. So we have an enciphered file. Let's close this, and now we will go back and open the file. So using our Certitude text editor, again, our demo app that is Amulet aware, it's now going to open, we're now going to open that Amulet protected file. And so that's this guy here. So open it, and there it is. So it opened, recognized it as an Amulet protected file, it's able to decipher it. And we're seeing it because the criteria from the Amulet have been met. So let's go mess up that criteria. Let's change it so that good test file.txt does not exist. So we'll just change the file name. Now, when we attempt to open the file, it says, hey, this was rejected. Now what it will do though, is it will display the header from that file, letting us know it is an Amulet protected file, and then it just doesn't display all the enciphered text. So we can close this.
Doesn't display, it probably can't display.
And let's see, let's go back
I
and
apologize, because I have to say.
restore.
We generally deal with I don't say non-technical audience, we deal with an audience that is a bunch of guys in IT shops So then the only thing they know about encryption is the standard encryption algorithms they've been taught, you know, that come preloaded with their. So we geared that to this, and I don't want to insult the people in the room, but we didn't know who was going to be in the room, so we kind of went down the middle.
But if you open a notepad, wouldn't you see all the gobbledygook?
Yeah, you'll see that.
You know, that's that right, so actually, I need
Yeah, we're gonna hit it here in a minute.
Our criteria, so that we can open that file. And then what I'm gonna do is I'm gonna save it as a different name, and then we'll compare the files, because there's another special aspect of the AMUmail technology. So I'm gonna save it. We're back in the familiar dialog, only this time it's already been populated with our last entries. Already selected AMUmail protected, it's plugged in our AMUmail config file, and it's selected our AMUmail ID. Before I save this, let's take a quick look at the AMUmail editor, get a feel for what is what's involved in the AMUmail. So it's saying you must be a logged in as an administrator. So I'm going to select the configuration file, and then it's requesting me to enter in the registration ID. So this is another key for the that would have to be known by the author. And then it's also requiring a login. And now we've got, so we're able to see the amulet that is in this amulet config file. And now you can see all the validations that are available. Now, what we're using is we're just using this validate files, and we're not even using a lot of the options within the validate files. Let's take a quick look at this one. So this is saying that this file, this specific file, here's the full path, it must exist. And that's really all we're using for this quick